All right, you guys, day 11, test review. Big day. What I'm going to do is go through a bunch of these. If you watch the whole video, awesome. If you want to just fast forward to the problems that you don't know how to do, that would be great too. Apologies in advance for the length of this, but I want to do a lot of these problems. I'm going to start with number 3, and after I do number 3, number 2 and number 1 are almost the exact same way. That's why I skipped those two. I'm going to start with number 3. I'm going to break down the 60. The first thing I think of is 6 and 10. Yes, there's other options. 6 breaks down into 2 and 3, and 10 breaks down into 2 and 5. I'm seeing a lot of people that think 10 is 5 times 5. Just be careful that you're actually breaking it down to two numbers that multiply to this number. 5 times 5 is 25. Be careful. Hey, I see a group of 2. Okay, and remember the numbers that didn't get circled, the 3 and the 5, those have to stay in. But the 2 comes out and multiplies by the 4 that's already there, which gives you 8. And then remember these two numbers that didn't get circled, 3 times 5 is 15. That is exactly how you're going to do number 2 and number 1 also. I'm going to do number 5, and then you'll know how to do number 4. So let's go to number 5, 98. Oh boy, what is that? 49 and 2. 49 is 7 and 7. Nailed it. Found a group of 2. 7 times 5 is 35. And yeah, I have X's and Y's here, so I'm actually going to leave myself some room. Maybe I'll write it down here. 35 on the outside. Leave yourself some room for the X's and Y's. And then remember this number, this 2 that didn't get circled, has to stay in. How did I get 35? Well, the 7 that came out gets multiplied by the 5 that's already there, and that's what makes 35. This 2 has to stay in. It doesn't have a partner to break out with. Now I'm going to do 10 x's. I have 10 x's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You might not have to write out all of these, but since this is just a normal radical with no little tiny number right up here, I know I'm looking for groups of 2s. There's one. There's one, there's one, there's one, there's one. There are 5 groups, so x to the 5th, and there's no x's on the inside because all the x's got circled. If there are any hanging out here that don't get circled, that's what has to stay in. I'm going to do the y's also. There's 3 y's. What that means is y times y times y. I'm looking for groups of 2. There's one group of 2, so y to the 1st. Do you need the 1? No. I'll erase it. But then this y right here that didn't get circled, that one has to stay in. So there's my final answer, okay? I'm going to do number 6 also. Number 6, see the difference? It's a group of 3 here, so I'm going to break down the 625. Did you know that it is 125 times 5? And 125 is 25 and 5. And 25 is 5 and 5. Wow, I'm looking for groups of 3 here. So look, I found one. That gets to come out. And this 5 that did not get circled has to stay in. I'll start writing my answer down here and leaving myself some room. I have a 5 on the outside. There's no number in front here that multiplies. So that's why it's just this group of 5 comes out. There's one group of 5. And there's a radical 5 on the inside. So this number that didn't get circled has to stay in. Now let's look at the A's. I have 5 A's. So A. Looking for groups of 2. There's one that has to stay in. So there's 2 that come out. And there's 1 that stays in. Now let's do the B's. There's 9 of them. Oh boy. 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe you already know how many groups of 3 there are in 9. Great. If you don't, do what I'm doing here. There's 1. There's 2. There's 3. So B to the 3rd. And there are no B's left over on the inside because they all got circled. Okay. There's my answer. Moving on. Let's do number 8. Remember, you can't add or subtract radicals unless they're the exact same. Remember, there was a question on the quiz that was like 6 radical 2 plus 2 radical 2. That means that you can add 6 and 2, which makes 8 radical 2. They're like terms, just like 6x plus 2x equals 8x. You're allowed to add them together if they're the exact same. That's what we're thinking about here for this problem. So just beware, radical is different from this one, it's different from this one. So what I have to do is I have to try and break them down, and we're going to see if any of them are the same to be combined. 20 is 4 and 5. 4 is 2 and 2. Found a group of 2. It multiplies by the 7 that's already there, so I get 14. 7 times 2. And then remember, this 5 has to stay in. Root 5. I'm going to bring down this minus sign. And I'm going to break down the 75. 25 and 3. 5 and 5. Found another group of 2. The 5 times the 3 makes 15. And remember the number that didn't get circled. This thing has to stay in. I'm going to bring down this minus sign. I brought down this one here. I'm going to bring down this one down here. And I'm going to break down 80. 80 is, let's see, 8 and 10. Yeah, there's other options. Running out of room. There's a group of 2. There's a group of 2. And I see a number that has to stay in. So the 2 comes out, multiplies by the 3, which makes 6. This 2 gets multiplied again, which makes 12. And the 5 has to stay in. Now let's look and see if there's any like terms that we can combine. This one and this one can get combined. What's 14 minus 12? Happens to be 2. Keep the radical 5 the exact same. And then this thing is a different radical, so I'm just going to write that at the end. So this and this I could combine together. 14 minus 12 makes 2, and they're both radical 5, so keep the radical 5. And minus 15 root 3 goes here. These are different radicals, so you can't combine them anymore. So we're donezo. Let's try number 9. When you're multiplying, this means multiply together when there's 2 parentheses like this. You're going to take the whole numbers that are outside of the radical. 3 times negative 7 makes negative 21. And you're going to take the numbers inside the radical and keep those inside the radical. 10 times 6 is 60. And I bet 60 breaks down. So I'm just going to do what I normally know how to do regarding radicals. I found a group of 2. That comes out and multiplies. So 21 times 2 is 42. And then what numbers have to stay in the radical? This 3 and this 5. So 3 times 5 is 15. Boom, shakalaka. Let's look at number 11. Oh boy, number 11 is one of the FOIL ones. How do I know that? I'm going to shrink this so I have more room. How do I know that? Because of the plus signs. This is a plus sign and this is a plus sign. This means FOIL. Okay, so when you're foiling, how do I know that this is a FOIL one and this one's not? So look at this one. This is all being multiplied together. 3 times radical 10 times negative 7 times radical 16. This is 3 plus root 2x, and this is 7 plus 2x. These are different. This means FOIL. This just means take your outside numbers together and put your inside numbers together, and then you might have to break that down. I would probably put one of these and one of these on your note card if you're making one. Okay? 3 times 7. That's what the F stands for, the first number times the first number, which is 21. Now I'm going to do the outside numbers. The O stands for this number times this number. When I do 3 times root 2x, I get positive 3 root 2x. This 3 is a whole number on the outside of a radical, and this is on the inside, so you can't magically shove the 3 on the inside. You just put it in front and then keep this the same. The I stands for inside, so that means this number times this number. And this is just like the one that we just did. So the 7 is on the outside and the 2x is on the inside, so this 7 is just going to get written right here. So it's positive 7 root 2x. And now the L in FOIL stands for last. So this number times this number. So I'm going to do root 2x times root 2x. Those are both inside the radical, so you're allowed to actually multiply the 2x times the 2x together. 2 times 2 is 4. X times x is x squared. I'm noticing that these two are like terms. Positive 3 and positive 7 makes positive 10 root 2x. You're allowed to combine them because they're the exact same. You have 3 and you have 7, and these radicals are the exact same. 3 plus 7 is 10. I'm going to keep the 21 that was in front, and I'm going to keep this plus 4x squared. And then did you recognize that this can be broken down? So 4 is 2 and 2. Found a group of 2. That comes out. And remember, x squared is x times x. That can come out also. So this whole thing ends up being positive 2x with nothing left over on the inside of the radical. So there's no radical left for this part. And I'm going to recopy everything else. This is my answer. Okay, that FOIL one, there will be one of those. Maybe star it. Definitely get it on your note card. Okay, just do one step at a time. Let's talk about the dividing ones. Remember that there's a rule about how if you have a radical over a radical, you can combine them into one giant radical. So that makes it 242 over 2. You can put everything inside one radical and pop that into your calculator. 242 over 2 reduces to 121. And did you know 121 is 11 and 11? It's a group of 2. It's actually a perfect square with no numbers left over on the inside. So 11 is your final answer for that one. Another strategy for these, again, I'm going to put this all into one radical. So 35 over 28. This radical or this fraction can reduce. Like ignore the radical for a second and just look at the regular fraction. You can divide both of these numbers by 7. Did you know that? So keep the radical because I haven't done anything about groups of 2 yet. All I'm doing is reducing the fraction and it gives you 5 over 4. So this means that it's radical 5 over radical 4. Remember, you're allowed to take a radical that has a fraction in it and you're allowed to split it up into 2 different radicals. I bet you know what this is. Radical 4, isn't that just 2? Square root of 4 is 2. So don't put a square root around it, remember, because the 2's break out and you actually have nothing left over on the inside. There's no numbers in here that didn't get circled. The top is just root 5. There's nothing that you can break down inside root 5. Remember the rule about not being able to leave a denominator in the bottom, or a radical in the denominator. That means you can't leave a square root like this in the bottom of a fraction. So how do we get rid of it? We times radical 7 on the top and on the bottom. And you just have to be careful about doing that because this is a whole number and this is a radical number and you can't times them together. So we just write them right next to each other. 2 radical 7. And then you know what happens in the bottom. Radical 7 times radical 7. It's times, not plus. We're not combining them. We're actually multiplying them. And they're both inside the radical. So 7 times 7 is 49. Yes, that breaks down with no numbers left on the inside. So we have 2 radical 7 on the top. I didn't change that. But on the bottom, root 49, it's a perfect square. The 7 comes out and there's nothing left on the inside. Remember, I can't cancel these 7s because this one is in the radical, this one is outside of a radical. So you actually can't cancel those. If you could reduce the 2 and the 7, those are both numbers outside of radicals. You could reduce those, but 2 and 7 don't reduce, so we're finished with that one. Number 16, I can't leave this radical in the denominator. I have to make it go away, so I'm going to multiply by root 2 on the top and the bottom. On the top, I'm going to keep the 4 on the outside, but I see 2 numbers that both have radicals with them, so 5 times 2 is 10. And then root 2 times root 2 makes root 4, and I bet you know what root 4 is. It's just 2. So I'm going to write my answer. I'm going to keep the top as 4 root 10, and the bottom is just 2, right? The square root of 4 is 2. And look, this can be reduced. 4 over 2 is 2. You can actually reduce that and then just keep the root 10. Yes, you're allowed to reduce those numbers together because they're both outside of the radical. 4 divided by 2 is 2. There's my final answer. Okay, and the next section that we did was rewriting, so turning them into, like doing the translation. What this means for number 18 is, I'm going to keep the 6. If it's a 6, if it's an x, if it's an a, whatever it is, but it's going to have a fraction exponent. And remember, the top number is what goes inside, so the 2 goes here. And this number in front of the radical is what goes in the bottom. That is what happens. How about this one? 7y. I have multiple things inside the radical, so I'm going to put them in parentheses. When there's only one thing inside the radical, like a number 6, you don't need parentheses. But in this case, I have a 7 and a y, so I'm going to put those in parentheses. And remember, when there's no exponent there, it's really a 1. And there's going to be a fraction here. And remember that the 1 goes in the top and the 4 goes in the bottom. I would definitely put a couple of these problems on your note card so that you remember where the top number is supposed to go and where this number in front of the radical is supposed to go. Let's see, in this one, let's see, I have a 12 and an x that are both inside the radical. So I have two things here, so I'm going to put them in parentheses. And this is a 5, and do you remember what number is here if there's no number there? Isn't it an imaginary 2? It's always there, so I'm going to put a 5 here, and I'm going to put a 2 there. Cool. That's just how to rewrite it as a fraction exponent. What about this one? This is kind of weird. I have multiple things inside this. So what I'm going to do is write 2 to the 9th, a to the 3rd in parentheses. And then remember, if there's no number here, it's just a 1 exponent. So I'm going to put 1, and then this 3 goes down here. Okay, and if we know anything about properties of exponents, I can actually kind of distribute this 1/3 to both of those exponents. So this is going to be 2 to the 9th to the 1/3. And this is going to be a to the 3rd to the 1/3. So you can make this 1/3 exponent go to the 2 to the 9th and to the a to the 3rd. And then we can actually reduce this. 9 times 1/3 is 3. And 3 times 1/3 is 1. That's our simplified answer. To be honest, if you understand this part, I'm happy. But technically, if you are a really strong Algebra 2 student, this is our simplified answer. Let me try this one. I have multiple things inside the radical, so I'm going to make it a parentheses. And there's a fraction exponent. Remember, this number goes on top, so 12. And this number goes on the bottom, so 6. And do you recognize you can divide this? 12 over 6. That means 5x squared, which technically means 5 squared and x squared. So 25x squared. Again, if you get to this point, I'm happy. 12 over 6 reduces. And then since you have multiple things in this parentheses, you can make this 2 exponent go to the 5 and to the x. 5 squared is 25. Let's try one more. X to the, there's a fraction exponent. The 4 goes on the top, and the 12 goes on the bottom. Do you recognize that this can reduce? You can divide the top and the bottom by 4, which gives you x to the 1/3. Dividing the top number by 4 and the bottom number by 4. Just a couple left, you guys. You're doing great. Thanks for hanging with me. Remember, if it's in a fraction exponent, you can rewrite it as a radical. The whole big number here is 57. And remember where the top number goes, 57 to the 1st. The bottom number goes here in the front of the radical. And as you know, you don't really need this 1 right here. You can put it there if it helps you, but it doesn't have to be in your answer. There we go. This one, I'm going to put the 9y inside the radical, and that's because everything in there goes inside the radical. And let's figure out where to put the 3 and where to put the 7. I'm going to keep parentheses around it. This 3 goes here, and this 7 goes here. Definitely write a couple of these down on your note card, okay? The 18 goes inside a radical. This is how to translate back and forth. The 7 goes here, and the 3 goes in front. Great. Couple left. Rewrite the following. This part says and evaluate, so we're actually going to simplify these. I'm going to turn this into a radical because I think better in radical form. Remember that the top number goes here and the bottom number goes in the front, so 5. I'm going to first start by breaking down the 32, and I'm looking for groups of 5. I'm going to ignore this 4 for a second. I'm just going to break down the 32. Did you know it's 16 times 2? 16 is 4 and 4, and each of those is 2 and 2. So look, I found a group of 5. I think that 1, 2, 3, 4, 5, those all get out. There are no numbers left over on the inside that have to stay. But remember this 4 that I ignored, that's going to come down, and it's an exponent on the 2. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. You're going to do number 28 and 29 the exact same way. Turn it into a radical. I would ignore the exponent, just bring it down at the end after you break down the radical like normal. Number 30, the last type of problem we're going to do, in order to cancel the exponent, you're going to times it to the 2/3 on both sides. You're not multiplying it, you're multiplying the exponent. So I'm raising this exponent to this, and that's what cancels, and we just get x on the left. 27 to the 2/3. I'm pretty sure I know how to rewrite that as a exponent. The 2 goes in front, and the 3 goes out front. Sorry, I misspoke. The 2 is what goes here. The 3 is what goes in front of the radical. I'm going to break down 27. It's 9 and 3, and 9 is 3 and 3. And remember, I'm looking for a group of 3. I'm ignoring this 2 for a second. I'll deal with that in a minute. But I have 3. I have a group of 3, which comes out. And then remember this 2 that I ignored? That's still an exponent that goes on the 3. 3 squared is 9. Let's try one more. Last one. You guys are doing great. I'm going to raise this to the 5/2, and I'm going to raise this to the 5/2. So make sure you know you're not doing multiplication here. This is an exponent. That's what cancels the exponents there, and I just get x. I'm going to put the 144 inside a radical, and this 5 goes here, and this 2 goes here. I'm going to put the 5 there and a 2 here. And as you know, I don't really need this 2. That just means it's a normal square root that I'm looking for groups of 2. Anyway, so I have 12 and 12. Oh, wow, I found a group of 2 already. Okay, excellent. I have 12 on the outside, and there were no numbers left over on the inside. And I have 5. So whatever 12 to the 5th is, that's actually a really big number. Let me see if I can pull up my calculator. Nope, let's see. Where's my calc? 12 to the 5th is what I'm looking for. 12 to the 5th. Enter. 248832. 248832. Huge number. No big deal. That's it. You guys ask me questions, okay? Thank you for watching. I think you're set up for success for tomorrow. Love you all.